So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 148 and we continue with our repetition of the keywords, and of course we extend a little bit our knowledge as well so that we get better. And like all time I will use cpp-reference.com as my website because this is a simplified version of the official papers, and of course our goal is to understand the official papers so we can watch all the keywords and all things about C++ in the official documentation and know how to use it, where to use it, when to use it, and all this kind of questions. With that said, I will start here again with my questions, and like all time I will read the question which I have here. Then you should pause the video and try to solve it on your own because you want train too, not just me, just watching me how I try to solve this one, because the point is that you train. And yeah, and I will then, after you tried it, then you can start the video again and see how I solved it, and you will see that I solved these questions not very well, which means I can't write all the answers here in this place here. And the reason for that is because these theoretical answers are, yeah, some are easy, but some are not so easy to explain it here, and would take too much time to write them all here. That's why I will all time refer to the site and show you here what they wrote, and you should read the official documentation here in this site. You will find the answers much accurate, and of course also not easy sometimes because they are referring to other things, but anyway, better than my answer here. But my answer will indicate the direction, or will just make an example of one case of, and there are probably more cases. So with that said, I start, and of course I will not pause the video, you should pause the video, and we get started. So here it says 56. What means the keyword return? All right, try to answer this. Then we have here another question, where we use it, and then do we need a return with void? And then here it says explain the example. So when I write here explain the examples, I mean all time the examples on this web page when you click on return and are on the page. But before that, try to answer this question, then jump into the page and try to explain the examples on your own. And now I get started. So what means the keyword return? Return in our case, let's write it here, can't also returns, I would say returns for the function before it ends. That's not so a good description. Let's say here with return you can return a value for a function, or you can stop the function faster, or you can stop the function faster. Okay, what this means, this is absolutely not accurate, but you will see it in a moment what I mean with this one. That was for this here. And the second one, where we use this and where we use it. We use it most time in functions. Let's say here most in functions. Let's write here in functions, because you want return a function, or you want break a function. I mean not break, you want stop faster the function, something like that. And do we need return with void? That's interesting, because void, when I talk about void, I mean here void function. Let's write here void function. That was not very good asked. Do we need return with void function? Because normally the return value is returning a value which should be the type here. At least it should match the type here with a function, but we have a void function here. So do we need to do we need a return with a void function? You can write it in different ways. First you can say as a as a return type not, but for other reasons we still could need it. And this other reasons is, what is this other reasons here? That's very important. I mean, in general, for the return type, if it's a function return type, you don't need a return because void means you don't use the return. But what other reasons you can have here to use the return, right? That's the important question here. And the point is, like I said, you can stop a function before it runs through all the function body. We make an example that, but before that, let's watch us the examples here on the page, which means we go here to the return. I click on it. Let's jump into it. And here we have the return statement. Let's jump into this one as well. And here, before we jump to the examples, we have here syntax. Let's talk about the syntax as well. That was strange that I don't ask for syntax, because syntax is very important as well. So let's talk at least at one syntax here. And it is this one. It says here attribute. I hope you know what this is by now. It is just an optional. We never see it in almost in programming, very rare cases, in very special cases. And then you put in this attributes. Attributes are here, this square brackets. Then we have here our return keyword and expression optional when we want, something express. And here we have not talked about expression in detail, but expression, let me click here to expression. It's normally very important too, but let's read at least just this first line here. And you can of course read here more, because expression, it's all time comes up and comes up. And there are different kind of expressions, careful, but let's read this line. It says here, an expression is a sequence of operators and their operands that specifies a computation. This is very abstract. It's not very clear, because now you think, hey, so I need here, for example, they make here an example with calculation, and it has nothing to do with calculation. It must be not a calculation at all. This is just one example with calculation, because when we go here and down to expression, you will see we have here many things which has nothing to do with calculations. For example, let me go to they have not made an example here. Why? Anyway, you can read this one. It must be not here. This one is good. You can see sometimes this looks not like a calculation. This is just a print out. Yes, just a print out statement, but it's still considered as an expression. So it must be not here operators with our operands, because when you read this kind of stuff, most people think of operators. Okay, operators are this kind of stuff here. And then many think about operands, something like literals, which they can compute together, which are math, and so that must be not the case. Very important in this case, it's not the case. You can see here, we have here not something like a computation of a math, anything. Read here a little bit more, and they will here show you what all are considered as expression or not. All right, that's very important, because this comes a lot of too. And here we have this expression, and here it must be not, like I said, a calculation. It can just a number, operand, can be expression, can be a calculation, can be expression. Yes, expression. All right, I hope it's clear, but it's optional. That's interesting too. We will see an example later. And here, let's see what we have here. Here we have, again, the second one is, okay, we have not talked about this one, so let's skip this two here. Let's watch this one. And here, braced init list. This braced init list we know now, right? This is this curly, the curly braces. And then you have here a list, which you can return as well. Interesting. We have never seen an example about this, but we have many examples of that in our tutorial. So this one was very rare, because yeah, we'll see in a moment why. So here it's a little bit description. We go here, we skip all this kind of stuff now. And what we have here, this one here, let's go to the examples, because we should explain the examples. Let me see what we can explain here. So try to explain, like it says here, explain the examples. So you jump here to the examples, and I think we can explain this here skip. We have not talked about this kind of stuff here, what we see here. This you can skip, and I think all other examples we can manage. Yeah, so try this one as well and try to explain this output. If you see something like examples here, the best way is you just run them and try to explain on your own, or so that you know why this output happens here and so on. And I get started now to explain this. So what we have here, first, we have a void function. This is a void function. We have a parameter int. And here is a if, again without curly braces. This is again the shortcut, you know. Don't forget, this is all time they use the shortcut. We use all time in this tutorial this curly braces because we are interested in the scope as well a little bit here. Yeah, we don't know. This return value might be stay here too, and then you have no clue what happens. And yeah, better you work with curly braces, but this one is used much time in programming. So with that said, here we have our first example, which is this one here. This expression is optional here, and that's why they can just use return and the semicolon, and here exactly this is this example. And here my question was here, do we need a return with void function here? And I said something as a return type not, but for other reasons we still need it. And here is exactly a nice example of that. Here we have a void. We don't need this return for this void here, but what we do here is we just don't want that this function continues if we have this condition. We say function stop at this point if I, which was our parameter, which was given in, you should just stop and don't execute this one. And the best way thing is you just copy this function here, copy, jump into your C++ IDE, delete all the other things which we don't need here, and paste it. And careful, what is that function? What we learned about function again? When we paste it on top, we can direct use it. When we paste it on the bottom, can I use it directly? No, but let's make it as well. Let's repeat this one as well. So I have pasted here a function below main, which means I will call this function here in main. But because it is here, I have to do what? I have to make a forward declaration. Let's repeat this one as well. Don't forget about kind of stuff like that, because if I would paste that on top on the other side, I would not make a forward declaration. And with that said, I can call this FA. Let's call this, and we have to call it with a parameter. How we call this again with a parameter, and what will do it? So let's call it, I call here FA. All right, with the parameter, let's make it with the parameter 1 first. So it is not this condition. And then let's print it out if this is working at all. We check this fast. And we see, and what we see here now is, yes, it worked. It is here, the 1 is printed out. And that's oops, sorry. That's exactly what the function is doing. Why it's returning us 1? Because here this line is executed and this line is just printing out our input, and my input was 1. Right, that was absolutely expected. And now we go here and make a call with 2, for example. Now I call it with 2. I start it again. And you see this time it's nothing here. And the reason for that is because this one is 2. The function stops here and is no more executing because it's return, and return means here go back to the caller here, and then it will jump here to this state. Can we check this actually? You can go and use here again this debug. You can see what happens here. The bug is jumping here. Now I'm here at the line. I see, and now I may dive in, and we see nothing here on the bottom, but let's go one more. I dive. You don't need to dive in, but here you can see this I. It says here I was 2. 2 is I was 2. 2 goes to return. Return jumps out back to to the caller, and now I'm here at this line here. It jumps to this one here, so it jumps back to the caller. The caller goes here because it's finished, and it would continue from this line here. And if I go on, it's back here on top to back to the caller here. Here I called. Here was the definition. Here it's back to the caller, and bang, it goes on. So I hope it makes sense. I called it wrong here. I said it gets back to the caller here. Here's the caller actually. Here I called the function, not here. Here is the definition. Sorry for that. Anyway, you understand it, I hope. Right? It was not too complicated. It was just a demonstration. So with that said, we have this. We have this. We can go back to our question, and we can go back to our curve, to our examples. So what we have here is another function, and what we have here is almost similar, but careful, we have now something different, right? We have here now a expression. In this case, it's just a number. And when we read here again this, here the expression can be, yeah, let's go here to expression actually. Where was it? Have I made this? No. We have here storage. I have made here something. Let's go here again. So here in this expression, here we have again, expression can be operators, operands, and in this case it is an operand. An operand can be, yes, anything. You have to read this again. And you can see here down, where are my examples? I have to go here down to the examples, and you can see this here is now an operand. It's just a number in this case. It's called an expression in this case, which means, yes, here we can return, but this time we are making two things at the same time. We check this condition, and we can break this function so that we have not execute this one here. And we are assigning, here we have a return value, which means we get here back information. And here, if this one is not the case, it will return us 2, which means we get again back information. So this function and this function, the only difference is here we will use the information with the return value here. So we already made millions of examples. I think I don't need this, but let's do it so that we have see this too. And again, I jump fast in, but this time I use the definition here on top, which means I don't need a forward declaration just for this case, so I don't have to. And this time I printed out, let's say, I have to call it so that I can print it out. So let's call it FB, and I call it with the 1 again in this case. And when I call this 1, but it has a return value here, I have to use it, right? That's the difference here. With a void function of the other one, you don't have to use the return value here, because this one was just to break the function and don't go on in this flow. And here, when you make something like this one with return value, you are interested in using most time, not all time, but most time you are interested in using this return value. That's why you make here a type, or if you are not interested most time, you would just make void to indicate I'm not interested in your return value. But I'm interested in your return value, and I want, for example, to make it simple, let's print this out. So let's print this out, because here, let's see what we are doing. When I go 1, it will go here. And let's make it 4. I call it with 4. So let's change this one 1, because if I call it with 1, you can see it will return, it will print out this one, and it will print out 1. But if I call it with 4, this one will, oops, I need greater, sorry. I can't use, I need greater, not 4, greater 4. So I have to call it with 5. Then it will return us 4. Okay, so, and this time it would print out nothing, but now I make a manual printout because I use this return value. And let's do it, let's test it. Yes, it's printing out 4 here because this one is return value. All right, we have repeat this one. I think that was too simple, too much talk about simple things, but it is a repetition. So yeah. we did it. So let's continue. And let's see the examples. Important is that you can distinguish these examples and understand why we have here a return, even we have not here a return type. That's important here. This one skip. This one, what we have here. We have never talked about this, but now I don't make this example as well. But this one here, you can see we have here, that's interesting and that's nice. We have here just another function call as an expression. Here, this is an expression, and I talked a little bit about expression. It's not looking all time like operator and operand, and here is an absolute nice example. We just can call here a function, and a function is an expression too. That's one here. So, and I think this one is simple now, because this return value is calling a function, which means, but let's call it how this works at least. I don't make an example now. I mean, I don't copy this example. I talk it now here. This works like so that this return value is just going here. This here is just jumping to FA, to the definition, and is using this 10 here, which means it puts in here 10. And then if 10, if I here is equal, also in our case 10 is equal to 2, it's not the case, it would return, so it will print out this one. So in our case, when you are doing this one, it will print out exactly this one, which is in our case 10. I hope you can understand. So in short, this one will be evaluated first, so it will be executed first, then this return, after this is finished, in this case, careful, it's a void. We don't get here a return value, but we don't need. And interesting is void expression, and you have to read a little bit void expressions here on top. They are talking about void expressions, how we can use that. If this is useful, we have not talked about this one, or you have to read this here anywhere. I don't know, there is a void expression, because you have to read a little bit about void expression if you want to understand this a little bit more in detail, because yeah, normally it's just executed here, and this was, and then yeah, you have to think about it a little bit, but it's easy normally if you are, after you understand it. So, and yeah, these are just the calls. I think that's it. We can skip them because they are calling then. Oh wait, I should explain here the output, right? So here the same thing here. Let's make it fast. FA2, like I before, FA2, I make here 2 in, 2 is equal to, it returns, and the first one will be output nothing. So the first one is nothing. Returns does nothing when I2. So that's cool. So we have figured out here is nothing, but we see here one, careful, this one is not for this one here. The one is for the second one, because now we have one here on top, we go here on top, it will not return because this one is not given. It will print out our input, 1 was our input, and we have 1. So then let's go to the next output. Let's see, what was this one? Here was this, okay, we have covered this one, and let's see what it's doing here. Here we declare and what is this again? What we are doing here in general, we're declaring a variable, it's a int. We are using the copy assignment, okay, and initialize it with the copy assignment here, okay. And we are using an expression which is a function. So this one means you have to first execute this expression here, which means you go to this, jump to this function. Let's jump it with the argument 5. And here it is called argument, and here when we jump into the function, this one here is a parameter. Just remember this, they are distinguishing parameter and argument. Argument means it's the actual value which you are giving into the function, and the parameter is just, yes, for the function here, to how you declare the parameters for the function. And with that said, let's execute this one first. So you start here, and it is 5, you just you jump here to FB, 5 in. 5 is indeed greater than 4, so this one will be executed. and it will return 4, and this one will be not executed. So we have here our second value is 4, not 5. Careful, why is this not 5? It's here is 5, but the return value is 4. It says only greater 4, and I will, doesn't matter what you give me in, I will return all time 4. So that's why we have here 4. And I think, let's see if I need this other two. So this one is clear. So I have executed this one, and here important, we have assigned this value as well to this declared value here. So now this I here is 4. So after this one, we know I have a value variable I is 4. And what is doing here in the next line? In the next line, it is assigning to this I variable here again an assignment. This time it's just a normal assignment, has nothing to do. Yeah, it's an assignment. It's still a copy. Yeah, let's call it just a copy, but because normally we say here copy initialization, and here it's just an assignment. And what this kind of assignment is, let's call it just assignment, so you don't get irritated with initializer and with normal assignment. And here we can say again the same play like before. We call a function which is execute first the function and then assign this value to I. In this case, fb I was what was it? It was 4, because our return value was here 4. For in fb here we have 4. Let me see something. fbi 4, and 4 is not greater than 4, because if I go fb with 4 and I have here 4 and 4 is not greater than 4, it will not use this one. It will just execute this one. It will skip this one. So with other words, I get a return value for 2. This is a return value which will be used, and in this case this return value is 2, which means I have here 2 assigned to I, and I get here an output 2. And the last one we skip, right? Is there something? Let's see, this pairs fc. Yeah, let's skip this. We have not talked about this kind of pairs. That's why we skip this one here. fd, let's see what this is. Is this something important? fd, we have here just an fd function call, and fd jumps here and it returns fa, and fa means just the same like here before. You can see fa just call with 10. 10 is not this one. It will execute this line, and we have here the return value 10 because we have here an output. Careful, we have here no output, but we have here an output. That's why we have here an output here 10. All right, with that said, that was total unnecessary, I think, because that was not complicated, but I just repeated in case. Yeah, I hope that makes a little bit sense. So let's go on. It's a repetition, and you are starters, and for starters it's anyway not easy. So I know for starters all this kind of stuff is not really easy. But don't worry, it becomes easy. The more you see, the more you do, it becomes more and more and more easy, and you get better much than me. No worry. So next question. Here, oh, that will irritate again many people, but let's read it and do it. So 57, is signed a keyword, type, or a specifier? Try to answer this one. And is that important to know? That's also a nice question. So signed, we are talking about signed here. Try to answer this question. So I'm answering it like this. Again, of course, not correct, but it's indicating again the right direction. So first of all, signed is a keyword. Is a keyword. Is signed a type or a specifier? Signed is a keyword, a type, and a specifier. I say it so. That's a little bit strange. You will see it in a moment why I say it so. Because that's not absolute accurate, but it is most of the time accurate. You will see. So signed is all of them. And yeah, we will see in a moment why. And is that important to know? Let me explain first this one in the documentation, and then we will see if this is really important to know. But in general, yes, it is important to know. All right, let's jump to the signedness of Where's this in fundamental types? So you see this list here with fundamental types million of times. And we talked about this here, especially this one here, many things. But let's answer the questions. First of all, it says here, is this a specifier here? Modifiers, okay, it's called here not specifier, it's a modifier, but my modifier is also a specifier, right? We specify the name which we are declaring, and you can see signedness, yes, we specify, we modify it by specifying it. Right, we have it. Okay, this one is definitely a modifier, a specifier. All right. Is this a type? Okay, let's see this one. This one will irritate many people, but let's say, is this a keyword? Yes, is this a keyword? But if it's not a keyword, I would not use it probably here. Here we have it signed. It's a keyword. Okay, we know it. This was also easy, but now type. This one will be a little bit irritating many people. And why? We have talked, oops, this is not the right place here in fundamental types. I have showed you this this list, and I said we have here type specifier, we have here equivalent type, and I showed you, hey, when you see this side here, they are actually types too, right? And I made an example with long, if you remember. So here on top we have long, it's also a modifier here, long, and long is also a type, I said you here, because this one is a specifier, because we specify here the size also. That's why it's also called a type specifier. But we have here something like an equivalent type here on the right side. And I made here something like an example. Let's jump to the main and make an example here. And let's get rid of all the other things here, which we don't need right now. And let's make here an example. And I declare a long, my long telephone number, and here I make it not very long, but that's not important. I'm interested in this long specifier. I made this example, and then I said, if you put here this debug, and you can check here the type, right? And then I started this one, and look what happens. We have here on the bottom the type specified by my IDE. It is long. And I said, yeah, you see? And then I said something like, yeah, you see? This type specifier, it is here on the side. It is not, it is a type, I said, even it says a type specifier. But we have here an equivalent type on the right side, and it says here, long int is the equivalent type. So now let's do the same thing here with signed, because when we look here, type specifier here, we have signed as well. What means this one? This one means, first of all, you can use signed without anything and use it as a normal type. Let's do it. I make something signed, and I call it my signed telephone number. All right, now I have a signed telephone number. And now let's do the same trick like before. We watch here the type, and I make here this breakpoint. And then I start this one again. And it jumps here to this line, and this one, this signed here, this is my telephone number. No, that was the long one, not this one. Here, the signed one. It says int. Wait a minute, but it says here signed. The type is int. So is this now let's go here back to our question here in this line. Is this now a type, or is this now a specifier? And the answer is, it is still a type, but behind the scene it is converted to an equivalent type. It is treated as an int. And you say, that's not true. It says int there, right? Because I started this one. It said, hey, it says int there. This signed is not a signed, it is a int. Yes, the reason is, let's watch it again. This signed here is treated equivalent to a type int. And the only difference is that this IDE is printing out and treating out it exactly like a int. So you are a little bit confused and say that's not true, but let me show you something interesting. So, and what is that? So that you get a little bit more confused. I showed you long, right? Okay. Look what happens when I use long int. Let's make here one more variable so that you get really confused. I make here long int. And now, oops, int. And now I write here my long int telephone number. And this one is a little bit longer, but that's not very important. Important is look this type here. Look this type, what happens. What is my trick again? I go here on top. This is so to find out this type. That's very nice. Because we will talk about types in a moment, because there was a second question. It was if this is important. We are talking about signed normally, but this one is very good to demonstrate. Here I start it, and look what happens now. I go here, my long telephone number, it is represented as a type of _int64. And when we go here to our table, we have not even this representation here. So what is then long int? Actually, it is a type of int64. But this table says, hey, that's not true. Equivalent type is long int, and you are not even showing that. That's a big problem, right? So what means that for us? The point is here, this here, the type what you see here is only used in the representation. Let's start this one again. This representation here of the type is used in Visual Studio as type int64. It is just a representation, but in general, you can think about it. This here type specifier, you can use these words, and its equivalent type is this one. And equivalent type means, and now the important part comes, equivalent type means they are creating storage. Like bits, they are creating bits, not storage. We can say it's bits. And important is what they are creating here, right? And this one are just, the type is just the name for the creation process of these bits here. That's very important. So if you have, for example, this long int, which says here in Visual Studio anything with, let's go here again, what it says here _int64. It means here more or less it will create here this one here, this 64 C++ 64, and you see all is 64, and that's why they call this just 64. Important is that you know you can use here this kind of symbols as starter. You can use this type specifier as a type. You can use the equivalent type as a type, and you have to be careful that you know what it means, because int here means I create at least 16. Careful, it says here at least 16, because here we have some other values in it. Here we have not really other values in it, but we can even go up here as well, possible, but not with this one here. That's why they say here also at least 64-bit. So in short, what you have to know is all time when you see this kind of stuff, you are most time interested how many bits they are create normally. So that's why we're interested in this type here, at least for numbers and so on. And that's not true also for other things. In a moment you will see. But here in this case, I want to just show you with numbers that they are creating a certain amount of bits. And that's the very important part. And in short, you can use all this kind of types. You can use the equivalent type. The only thing what you have to know is what they are creating. And there is, I think that's my next question. Let's see if this is there. My next question. This is my next question. Yes. here is this operator where you can check it. We will talk about the Sizeof operator in our question, but before we go there, there's one more thing what I have to tell you. But let's use the Sizeof operator so that you get here an idea. If you don't know exactly, let's see how long this on your machine is, this type, then you can print something out and use the Sizeof operator of, and then long int. So, and now I print this out and I print here a 8. What is 8? Careful, Sizeof operator use all time bytes, which means these are 8 bytes. And if you have 8 bytes converted in bits, 8 multiplied by what? 8. And this is 64 bits, not 65, 64 bits, right? And this is indicating this, when I start again this debug here. No, what is the problem? All right, this should be a comment here, of course. Let's start here again. And you can see this int 64 is indicating this one will create 64 bits long. This type is 64 bits long. And then you can make your numbers. So one more step. Why is this important that I know? Because the other question says here, let's jump here. It says here in my question, is it important to know? And the answer is yes, it is important to know. But we are talking about signedness, right? Why is it important to know the type and the signedness? And it's very easy, because let's say you are working with very small numbers here. Then it's important that to know, for example, just 8 bits is just 1 byte, how many values you can put in. For example, if you write here in this in this char a value 400, it will not work, it will break. So it's important to know how many bits you have. For this int, for example, it's important to know, or let's say for the signed here, it says is int, but when I use this one here, let's go here, I can write here signed, right? I can, let's this one out, start, it points me out now here, oh, my signed has 4 bytes, which means 32 bits. Now I know this one has 32 bits, and I know which number I can put in. We have talked about how you can get these numbers for 32 bits, for example. That was in my last video where I said, hey, integer here, 32 bits here, you can unsigned would be 0. Okay, this is not here, 32 here, unsigned. Signed would be go from -2 billion around to 2 billion, and unsigned would go here for 0 to 4 billion. And it's very important that we know it is signed or unsigned, because if you use this value signed like it shows here, you can use minus and plus, and the value changes, right? The value range changes here. And that's why it's very important that we know if it's signed and not signed, because this signedness you can set in C++. And so you see, you need to know the signedness for this value here, if it goes to plus minus, and you need to know signedness here in this table, it is equivalent type and to what it is resulting, so you know how you can calculate this one, 32 bits. And yeah, these two values here actually are also 32 bits. You can see this both are 32 bits, but important is if it's signed 32 bits or it is unsigned 32 bits, and you see the value is changing dramatically. So it's very important to know this. Okay, I talked again much about it. So the short answer is yes, it is important to know. Is that important to know? Yes. Yes. So you can use right values. I write here in short. Right? So that's my very short answer. Again, you see, very short and not accurate. But you, if you see my explanation, it's okay. And of course, read it on your own. That's why we make this specification here, to learn this documentation. Then you can read it on your own and understand it even better than me. All right, with that, let's continue a little bit. I mean, I talked again so much, but let's go. The Sizeof operator, we just used it. So let's go here fast because this one was not very difficult. Let's make this one. First of all, what is the keyword Sizeof? It is the Sizeof operator. Okay, I told it already. But here, try to answer this one. Why we need it? And then make an example, explain the examples on the page. Oh, all right. So I trying to answer this one very fast, this case. First of all, what is the keyword Sizeof? Yes, it Sizeof shows you the type size. Type size. So more or less, this is a short answer, but we will read the real answer too. But the type size, you can type in like I showed you here in my example, by the way. Here, I typed in the type, and the Sizeof operator gave me back a value which was in bytes, and I had to multiply it with 8 bits because 1 byte has 8 bits, and then I know how big, for example, signed is in bits, and bits I can calculate the numbers, for example, how much I can put in which numbers and so on. That's the reason for this one. All right, let's go on. That's here. Then it says here why we need it. So why we need this one? Yes, to see the type. Let's say to check type size. That's again this short answer to check type size. Like I said, if it says 8 bytes, then you know, this type has 8 bytes, the other type has perhaps only 1 byte, depends on the type, right? Here, different types, different bytes. For example, character can have a range of this one, but in general, it has, for example, 8 bits. How I can check this on your machine, what you have to check this because perhaps you are not working on a machine which has 8 bits and you thought, hey, it's all time 8 bits. That's not true. It says here size in bits, and we have here ranges. You have to check on your machine, on your PC, what you are working, if it's really 8. If it's not 8, then all your programming can go wrong, and that can cause a big problem. That's why just make sure that on your machine the size is exactly expected. Let's say I expect 8 on my PC. This one here, I don't expect I have this one. You can see it's anyway other format here, but I expect this one is by default. Let's see if this is true. What you do is, let's copy this one here, copy this one, paste in, and say here, for example, character, and the shortcut for character was car. All right, and then we can delete this one as well, and let's comment this out. All right, and let's start and see. So now I check it and see, yes, it's 1 byte. 1 byte is 8-bit. And it's indeed this version here. So I know I can use these values for my character. And just one more thing, by the way, why we have here numbers for characters. Think about the ASCII table. You can convert characters to numbers and back and forth. Will be very useful for... Yeah, we will talk about this in another video, but just think this one is very important to know for kind of stuff of like that. So with that, let's go back here and jump here to this one, and let's see why we need it. Yeah, make an example and explain the examples on the page. I think I made here an example here. Okay, here are the examples. Here I have here a variable, and then I made the example how to get this variable size. So I made many examples here, but let's jump at least to the page then and see what they make with this Sizeof operator. And there is one more thing. Actually, there's another Sizeof operator. I have not shown you that. Let's go here. Here is this version of Sizeof operator, because we have here 2 versions. Let's click this one. And this one we skip now because now we have here a parameter pack. And yeah, and they make this is just with more parameters. You can and this examples I can't explain you because we have not talked about templates. When we talk about templates in this tutorial, I will explain these examples as well. That's why let's skip this one at least and explain the normal examples which we have here in our, where is it? In this operator, Sizeof Operator. Let's go here. Here in this one. And here are some examples you can see. And you can try this on your own. The problem is here, this one has also something which we have not talked, which is this word struct, which means it's creating more or less a class, similar to a class. It's almost the same. But the problem is we have not talked about it, and there are many things which you can irritate. But important to know is here as shortcut, this struct here behaves like just a container in this case, because they are just creating variables in it and not more. And most time they use struct like a container for variables, which means you can forget this one here and just concentrate on this curly braces and try to figure out why we have here these numbers. And actually, when you watch this closely, they are just calling here in main, here in this output, they are trying just to call Sizeof, and the operator, interesting is they are not using this this round brackets like in the definition here, big, because they are using the second syntax, just expression, and here it's a type when you're asking for a type, and here they're asking for an expression. And you see this one, this A is not a type, it's here an expression, it looks like. Then this one here, because they are just creating some okay, we have not talked about creating an object of a struct. We have not talked about this, but here they create just the object, and then they say how big is this object, and then you can see here on bottom the object size empty class is 1, and then the second one is, okay, let's forget it, perhaps, these examples, because they are using all the time this object. But in general, what they are doing is exactly that, what I did here. They have some types, they have some expressions, then they are using here the Sizeof operator, and they are just checking here how big this is. And you can go through and read this on your own and see what you know and see what you don't know. And yeah, I think I skipped this because that would take too long, and they are just calculating here the sizes and so on. Okay, I think you can do this on your own and skip all the other things what you don't know. Here is again something what we never see so often. We have here indeed an attribute, and how I can see that this double square brackets. We see that's not often because most avoid this, but here we have here an attribute, interesting. And yeah, let's skip this. I mean, I can explain it, but that will take much time, and it's not too difficult because it's exactly the same thing here what they do. The only difference is they have also expressions. So they use also expressions here. In my case, I have only made examples with types, and they make this expression. If you want, check this one out, what they mean with expressions here in the examples. All right, with that said, let's see if I can add one more question, or I should make a break here because it began, I talked again so much, right? And I think when I talk too much, I should make a break because this one goes on. Yes, I think it's a nice place to make a break because the other things is a big topic again. And there I need again much to talk, and that's why we make here again a break. So with other words, if you have any questions, any complaints, any tips and tricks, write them in the comments below and train all this kind of stuff. And don't worry if you don't understand anything as a starter. For starters, this kind what I talk here can be very, very confusing. That's not the point here that you get confused. The point is here that you just get used to it, even if you don't understand it, because you should just try. And then if you don't understand it, don't worry about it, because you get better and better and better with the time. And later, you will just go over it like a rocket and don't care about keywords and the stuff like that, because you care it only at the start. When you learn this kind of keywords later, you just use them automatically without thinking, and then you will just still come back sometimes just to see what's the official documentation saying about some keywords and use cases. That's why we make it, because sometimes even you know most of these words here later, you still come back and say, what are these little exceptions there, and how I can see, that was here an exception, there an exception, and still you need to read the official documentation. And that's why it's so important that we are able to understand at least this documentation. Later we switch to the official documentation after we finished here, this basics here at least. All right, with that said, bye, good luck, don't give up, we get better and better, and see you in the next.